use the trapezium rule with 3 intervals to find an approximation to the definite integral. Your answer must be correct to 5 significant figures. We are actually finding the area under the curve of 6 over 1 plus root x from x equals 1 through x equals 4. We have x equals 1, 2, 3, and 4. So we need to find the area of each trapezium from 1 through 4 that is under the curve of 6 over 1 plus root x. So let's say x0 is 1, x1 is 2, x2 is 3, and x3 is 4. Then we need to find the y values. To evaluate the y values, when x0 is 1, then y0 is 6 over 1 plus square root of 1. That is 6 over 2, which is 3. When x1 is 2, y1 is 6 over 1 plus root 2. We'll just leave this because your answer must be correct to 5 significant figures. Just dump everything into the calculator later. x2 is 3. So y2 is 6 over 1 plus root 3. x3 is 4. y3 is 6 over 1 plus root 4. That is a 2. 6 over 3 is a 2. So these are the y values that we have. And we are going to use all these to find the area under the curve using the trapezium rule. So from the trapezium rule, we know that the area under the curve of 6 over 1 plus root x dx. This is approximately given by 1 over 2. This width here is 1, so h is 1 multiplied by 1. We take the first y value plus 2 times the second and the third one. We have 6 over 1 plus root 2 plus 6 over 1 plus root 3 and add to the last value, which is a 2. To 5 significant figures, this is 7.1814. For part B, we need to find the exact value of the definite integral of 2e to the 1 over 2x minus 2. So we just integrate this. Upon integration, we have 2e to the 1 over 2x minus 2 multiplied by the reciprocal of this, which is a 2, and we evaluate from 1 through 4. We have 4e to the 1 over 2x minus 2 that we evaluate from 1 through 4. Now we replace x with 4, so that gives us e to the 0. And when we replace x with 1, we have e to the negative 3 over 2. Therefore, the exact value of this definite integral is 4 minus 4e to the negative 3 over 2. Part C, we are given a diagram that shows the curve y equals 2e to the 1 over 2x minus 2 and y equals 6 over 1 plus root x. The shaded region, this is the given shaded region here, and we use our answer in parts A and parts B to find an approximation to the area of the shaded region. So we need to find this area A here. So this area A is actually the area under the curve of 6 over 1 plus root x from 1 to 4, and we subtract the area under the curve of 2e to the 1 over 2x minus 2. This part from part A is 7.1814, and from part B, this is 4 minus 4e to the negative 3 over 2. This area is an approximation because the area under this curve here, the first curve here, the upper curve here, is an approximation. So that will give us 7.1814 minus 4 plus 4e to the negative 3 over 2. The double negative cancel to be a positive. And to three significant figures, we have 4.07. So that is three significant figures. Part D, state with a reason whether your answer in part C is an overestimate or an underestimate of the exact area of the shaded region. So this part here is exact. This is approximate. So from here, exact and approximate, we have an overestimate in this case. Now this part here is exact, and this is approximate. So whether you have an overestimation or an underestimation, it depends on this approximate area. And you can see that this graph here of y equals 6 over 1 plus root x, this is concave up. And when we draw a trapezium using this, you see that we actually have an overestimation because the top part of the trapezium is above the curve that is concave up. And since this area is an overestimation, we minus a subtract an exact area, we actually have an overestimation.